Hi, Mr. Knight. For this video, I'll be going over derivatives, and I'll be showing multiple examples of how they can be represented graphically, numerically, analytically, and verbally. So derivatives can be shown in the first way, which would be I'm going to show graphically. And graphically, derivatives, what they do is they will take the original function, and if you take the derivative, so this is the original function. If you go up here, you take the derivative, if you plug in points into this equation, you will get the slope for the original function. So if I plug in 1 into the derivative of fx, you get 3. And so for the function fx, that shows you that the slope of fx at 3 is at 1 is 3, and then you can show that by drawing a tangent line, and that will show you the slope on a graph. And then if you wanted to use derivative for analytics, you can also say this equation right here, gx, is the equation of my company's income by month. And so this would be month 1, month 2, month 3. And so to find the rate of income in the first month of my company, I would take the derivative of gx, which would be 4x, and then you would get rid of the 1. So the derivative would be 4x. And then I would plug in 1 for 1 month. So, and that equals 4. So, and if I'm going to have the units be thousands of dollars, so in the first month, my rate of making money was $4,000. And this would be at that point, I was making $4,000 in a month. So, and then if you were to compare this to other months, you would probably, if you go to the right, you would be making increasing amounts of money. And if you go to the left, you would be seeing negative amounts of money, because these slopes or rate of changes at these points would be pointing negatively. Other ways you can see the derivative used verbally is through people using words such as speed and velocity. Speed, which would be the original function, and then velocity being how fast that function, or say the car, there's a car going down a raceway and it's accelerating at the start of a race, you would be able to see the speed that it's currently going, the rate at which it is changing, which would be the first derivative, and the acceleration, which is how much speed is increasing over time. So like it would, if it's like slowing down, the acceleration would be negative, but if it's increasing speed through like start of a race compared to after the race ends, it's going to go negative acceleration, but when a race starts, it's going to have positive high levels of acceleration as the car is starting to move. And then you can also represent these numerically as if you have just an equation of, this is like a equation where 3x7 plus 15x is the rate of change for eggs birthed per month by chickens in California. And you could use this equation. And then if you want to see how many eggs were birthed in a month in California, you would be able to take a derivative of this equation at that certain month and see the rate of which chickens were producing at that certain month. And those are the different ways you could be able to use derivatives. Thank you for watching.